Happy hump day, guys. Today's lesson is modeling multiplying a decimal by a decimal. And so for the past 2 days, you've been focusing on multiplying a whole number by a decimal. And today we're going to move to multiplying two decimal numbers. So both factors will be decimals, with the emphasis on the modeling. Now on Monday, Mrs. Gerhardt said you guys didn't really understand why you had to model, why you had to color, but I think I explained yesterday that that is part of your learning as a fifth grader, and this concept is the actual model. So that is today's lesson, is the modeling of a decimal number multiplied by another decimal number. Okay, so let's remember what it looks like to model a whole number multiplication problem on a grid. Keeping in mind that the when we're modeling a whole number times a whole number on a grid like this, we're picturing using the base 10 blocks that there would be two of the flats right here, and that each flat represents 100, an area of 100 holes, and that the longs are representative of tens, and then the unit blocks are representative of one, or one hole. So this is something that probably makes you think of the box method that we used at the beginning of the year, where you multiply, well, first of all, you break apart the factors by place value, so 24 times 13, and you multiply each part of that to get your partial products, and then you add the four partial products together. Okay, so hopefully that kind of rings some bells for you, and some light bulbs are going off as far as you remembering about what that looks like. Okay, so here's what you did on Monday, was modeling the product of a whole number times a decimal number. So you were coloring in multiple groups, or multiple equal groups of the same decimal amount. In this case, it was 4 groups of 36 hundredths. And so you would color in your first group of 36 hundredths, and then your second group using a different color, your third group using a third color, and the fourth group using your fourth different color. And then if you count up the total, it will give you your product, which would be 1 whole and 44 hundredths. Now keep in mind, when we are playing with decimals, we think about the grids differently. Whereas this would represent a 100 flat whole number, back when we were dealing with whole numbers, when we deal with decimals, we think of a grid differently. We think of that this is divided, well, they're both divided into 100 equal parts, but if you're thinking about this as a whole number, then this represents 100. But when you're thinking of it as a decimal representation, you're thinking of it as a 1 whole, or just 1, divided into equal parts. And so each one of these parts is 100th of the whole, and each column or each row is considered 1/10 of the whole, just like a unit cube and a 10 flat, or a 10 long. 10 long. So that's what a whole number in a decimal looks like modeled. And here is a decimal times a decimal modeled on a grid. And so that's what we're talking about today. and tomorrow is a decimal times a decimal. So you'll notice that it looks way different than anything that we've done before, but you still see that there's an area here that's kind of this overlapping area. And so instead of, you know, 3 groups of 5/10 or 5 groups of 3/10, we have 3/10 of 5/10. Or you could say we have 5/10 of 3/10. And so that's a whole different way of thinking about multiplication. You're taking a part of a part. And so you're actually going to end up with a smaller product because you're taking a part, because that's what a decimal is. And when I say a part, I don't mean a part. I mean, I don't mean taking a part like subtraction. I mean taking a part like a fraction. So anyways, so you can see here that this right here, this area right here, is talking about 5/10 of the grid. So 5/10 have been colored in vertically. And then this, from here to here, is pointing to the fact that you have 3/10 colored in horizontally. And this area that overlaps, where the purple and the green overlap, is the area of the product of these two numbers. So 3/10 times 5/10 would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 hundredths would be your answer. It's the overlapped area. Okay, so I just want you to watch the first one. Just kind of watch what I'm doing, and then after this one you can join in. Mrs. Gerhart will give you some grid paper, and you will model yours as I'm modeling mine, and we'll color at the same time. But right now I just want you to watch this one and kind of get an idea of what's going on. So I'm going to model 6/10 times 7/10, or 6/10 of 7/10, because remember, multiplication means groups of. So you can also say 6/10 of 7/10. So we're going to come out with a very small number because we're taking a part of 7/10. So the first thing that you're going to want to do is you are going to look at the first factor, which is 6/10, and you are going to color 1, 2, 3, 4, 5, 6/10 going across this way, because one of these 10 hundredths is 1/10, right? What I'm saying is 10 hundredths, which would be that, is equal to, that's a decimal, it's not working, but is equal to 1/10, which would be this. And so you know, you've known that before. We've compared decimals before. We know that we can put a 0 here. We know that these two are equal, but that's kind of a picture of why they are equal. So let me back up a little bit. So I'm going to color in 6/10 going horizontally. So 1, 2, 3, 4, 5, 6. So from here to here is my 6/10. Now I'm going to color in my 7/10 vertically and with another color. So that would be 1, 2, 3, 4, 5, 6, 7. And so from here to here, that represents 7/10. Okay, so you see the area where they're overlapping. That is this area right here. So there we go. This is the area where the two colors are overlapping. And I mean, think about it. When we talk about whole number area and we say, well, it's a 2 foot by 3 foot area. Well, this is 6/10 by 7/10 of an area. And so we're just talking about these pieces being small, a lot smaller than whole units. So then you would just count up your the quantity in the inside of the area to get your product. And so since there's 1, 2, 3, 4, 5, 6, 7 by 1, 2, 3, 4, 5, 6, we know that 7 times 6 is 42. So if I were to count up each individual square or hundredth, I'm going to get 42 hundredths. So our answer to this problem is 42 hundredths. Okay, so this one you're going to color with me. So Mrs. Gerhardt will give you some grid paper like you had on Monday. You will need your colored pencils or your crayons, and everybody should have those in their binder because that is something you should have in class every day. Right. So that's what you'll need. So if you need to do that real quick, she can pause this, and then you guys can color right along with me. You'll also need your pencil so you can mark the area of or the dimensions of your problem. So the problem that we're going to do next is 7/10 times 3/10 or 7/10 of 3/10. And so with your first color, you are going to represent the 7/10, and we will color that vertically. I'm going to use yellow. And so here we go. 1, 2, 3, 4, 5, 6, 7. And at any point, obviously I'm going to be coloring a little bit faster, so Mrs. Gerhardt can pause this and wait until you have finished coloring, then she can hit play again. So don't feel like you need to rush. So with your pencil, then you're going to draw your little bracket here that shows me that you understand that that portion that we just colored represents 7/10 of the grid. Okay, now we're going to represent 3/10 of the grid with our other color. So 3/10 is our other factor. Okay, so 1, 2, 3. So our product, again, is the overlapping part, or the part where you can see both of the colors. That would be this part right here. And black. So we have a 7 by 3 area, and we know that 7 times 3 is 21. If we were to count each individual square, let's just go ahead and do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So our answer is 21 hundredths, or 0 and 21 hundredths. Okay, for the next one that we're going to do together, we're going to model 4/10 times 6/10. And so, just like we've been doing, we're going to color in one of the factors vertically and one of the factors horizontally. Okay, so 6/10, 1, 2, 3, 4, 5, 6. And then 4/10, 1, 2, 3, 4. And then our product is the area that's overlapping. It is a 6 by 4 area, or 6/100 by 4/100 area. So we know that 6 times 4 is 24. And so our answer would be 24 hundredths is the area there. So our answer would be 24 hundredths. Okay, so for the next little bit of class, I want you to, on your grids, I want you to practice modeling these products by coloring each of these. I think there's 6 different problems, and I want you to model each on a different hundredths grid that you have. Using 2 colors. You can change the colors each problem, but make sure that you color each factor horizontally and then vertically, and then label the area with your pencil, and then write the area or the product inside the actual grid like I did, or outside, just right outside the grid, or right under it, write the product. And so this should take you a little bit of time. If you have some time right after this, after everybody's pretty much done with the coloring, then I'll have one more slide of something that you can think about before we start actually using the algorithm tomorrow. So have fun coloring. Yay! Coloring's fun. Okay, so let's think about a little bit larger of a decimal number. So something like 1 and 2/10 times 6/10. So obviously I already have 2 decimal grids here, so your brains were probably already kind of thinking, but just have Mrs. Gerhardt pause this video at this point and just talk to your group, elbow partner, eyeball partner, whatever she wants you to do. Just talk about what you think the product will look like, and what the area of the overlapped area will look like, what the product might be. So just go ahead and pause it right now and talk about that for just a couple minutes with the partner, and then she can hit play again in a minute. Okay, so when we are talking about a mixed number, which has a whole number part and a decimal part, it's going to look just a little bit different, obviously, because you have one entire grid filled up, because one entire grid, or 100 hundredths, is a whole. So I'll go ahead and color that real quick. So 1 and 2/10 would be obviously the entire 10/10 or 100/100, and that's 1 whole. Plus you have 2/10 of another. Okay, and then with the 6/10, you're going to do the same. You're going to color the opposite way or horizontally, but you're going to color in 6/10 of the entire picture, or the entire 1 2/10. So that's kind of weird, but still same process. So 1, 2, 3, 4, 5, 6. So your product is here in this overlapped area, just like we've been doing. Right, so you have in this area right here. Oops, I didn't label my, let me go back and label my dimensions. So right here you have 10, and then 2, and then here you have 6. So your area here in the middle is going to be a 10 by 6, which is 60. So 60 hundredths, because each piece is 100th. And then on this grid over here, you have a 2 by 6, and that's 12. I don't know if you can hear my cat, but she's talking to you guys. So that would be 12 hundredths, that part. And so we have 60 hundredths or 6/10, plus we have 12 hundredths. And so if I line them up vertically like this to add them together, if I can't do that in my head, I'm going to drop my decimal straight down. I'm going to add the, just like normal. So I would get 72 hundredths. So your answer here would be 72 hundredths. So that's how that problem would look on a decimal grid. You would need, sometimes you might need 2 or 3 decimal grids. It just depends on how big the factors are. Okay, so I don't even know if you guys will have time for this, but if you don't, Mrs. Gerhardt can show this tomorrow. It could be the first thing that you do. So look at this question and the representation or the model that it's showing you, and you are going to do a think, pair, share. So you're going to think to yourself. That's no talking, so total silence in your own brain. You're going to think about what this model represents, and then look at your answer choices and see if you can figure out which answer choice you think is correct. Then the pair, remember, you're going to pair with a partner. So Mrs. Gerhardt will tell you either your elbow or your eyeball partner, and you and your partner will discuss for a minute or so. And then Mrs. Gerhardt can call on a couple of you to share out what you or you and your partner were thinking and why that you picked the answer that you did. So we've done that once or twice before, a think, pair, share, but I'd like you to do a think, pair, share on this problem just to kind of either tie up today's lesson or start Thursday's lesson. So I hope you guys had fun coloring today, and I wish I could have been there with you. And I hope that you're understanding a little bit more now. If you aren't, just like we always say, this is a brand new topic. This is one of those skills that came down from middle school. So if you're still a little bit confused about it, it's okay. We will definitely work harder and we'll practice more. So don't worry or stress if you aren't quite 100% yet. It's okay. And we'll get there sooner or later. Bye. Y'all have a good day.